Sir, your screen is.
Now you can see.
Yes, sir. Now we can see.
Chalo, can I clear 29th?
Yes, sir.
थोड़ा कॉन्सेप्ट वाला चीज देखते हैं कि कौन बराबर बोलेगा. Body A, body B, body C. I throw this by speed of 10 kilometer per second. This by 11. This by 12. This reaches up to height h1. This reaches h2. This reaches h3. Now what I do reverse. I drop one body from height h1 reaches to the ground, that is A. Another body from height h2 reaches to the ground. Third body from height h3 reaches to the ground. Can you tell what will be velocity of A, B and C when it returns back? 10 से फेंका h1 पे गया, h1 से ड्रॉप किया तो स्पीड कितना होएगा, ये क्वेश्चन है मेरा. B से थ्रो किया, 11 का स्पीड h2 पे गया, h2 से ड्रॉप किया, स्पीड कितना होएगा? ध्रुव,
10 किलोमीटर पर सेकंड वाले का 20 हो जाएगा.
अच्छा नहीं, सेम टू सेम रहेगा ना. 10 वाले का 10 रहेगा, 11 वाले का 11. खाली
ग्रेविटेशनल फोर्स की वजह से
नहीं, देखो खाली इंटरचेंज हुआ ना. इधर जो दिया आपने वो काइनेटिक था.
यस सर.
इधर वो पोटेंशियल हो जाएगा. सेम हाइट से रिटर्न आया, फिर से वही काइनेटिक आएगा ना.
समझ गया सर.
हाँ, तो कभी भी इतना याद रखो, अगर आपने एक वेलोसिटी से फेंका, वो कोई तो हाइट पे जाके रुक गया, फिर से उधर जब नीचे आएगा ना, सेम वेलोसिटी आएगा, अलग नहीं आएगा. बिकॉज वी आर एज्यूमिंग देयर इज नो एयर और करंट और फ्रिक्शन. ओके,
अंडरस्टूड सर.
तो अनमोल, यू जस्ट टेल मी, with what speed if I throw the body it will go to infinity from the surface of earth?
Sir, it should be root 2gr by r. Means it should be greater than root 2gr by r.
No, you tell me numerical value from the surface of earth. I want to escape it so that it goes to infinity. So how much I should give the velocity? We all know 11.2.
Yes sir.
Okay. तो अभी ये क्वेश्चन क्या बोला देखो. A 10 kg body is dropped from infinity, not thrown, dropped. Then it will reach to the earth with what velocity? No need to calculate. What you will write? 11.2.
Yes sir.
Now by calculation, when we drop from height to the surface, that means gain in kinetic will become loss in potential.
Yes.
Correct, na? So that means this is minus gmm upon r plus infinity plus gmm upon capital R, minus minus plus, loss in potential. This line clear? Anything upon infinity is 0. Hello?
Yes, sir.
So
Yes.
half mv square is gmm upon capital R. That means v is 2 times gm by r in root. ये किसका फॉर्मूला है? escape velocity का ही है ना?
Yes sir.
Yes, sir.
मतलब वही आंसर आएगा ना, 11.2.
Yes sir.
Okay, write in word. When we throw a body, when we throw a body with 11.2 kilometer per second from surface of earth, it escapes. Hence, when we drop from infinity, its velocity on Earth's surface will be 11.2 kilometer per second. Nija, clear? Nija?
Yes, sir.
Okay, followed now this one?
Yes, sir. Wait, sir.
Read and see whether you understood.
Yes, sir.
Yeah, write down.
Yes, sir. Done.
30th. The radius of Earth is reduced by 1%. Mass is constant. Escape velocity will be how much? Escape velocity is 2 gm by r in root. Mass constant, m constant. So VE is proportional to 1 upon root of r. That means VE proportional to r raised to minus half. Now when error is less than 5, we can use our percentage error of measurement chapter. Percentage change in escape, r is decreasing, here power is negative, so percentage increase in VE. When power is negative, one will decrease, other will increase. Because r is decreased, so VE will increase by power half into change in r, into percentage change in r. R change is given 1, so it will increase by 0.5%. Option A. Okay, clear now?
Yes, sir.
Fine, fine, fine.
Yes, sir.
Done. Okay. 31. Escape velocity of particle of mass m. Escape velocity is 2 times gm by r. Can you see anywhere mass of particle which is escaping?
What, sir?
Can we see mass of particle, escaping particle का mass here? ये g is universal constant, ये mass of earth है, ये radius of earth है.
No, sir.
So can I say VE is independent of mass of escaping body? Therefore, VE is m raised to 0. Option C. Does not depends upon m raised to 0.
Yes, sir.
Okay, done. 31.
Just a second, sir.
32 it is, sorry. In your PDF it is 32. Next. Escape velocity of a body from surface of earth is 11.2 kilometer per second. It is thrown, means projected, with velocity 4 times escape. That means Vp is greater than escape. Velocity of the body when it has escaped, the gravitational pull of earth is approximately how much? Vp is greater than V. Since Vp is greater than V, so velocity of emergence is root of velocity of projection minus escape square. This I had told you in note. So projection is 4 times VE minus VE square in root. 16 VE square minus 1 VE square in root. So this will become 15 VE square. Root 15 into VE. Okay. And VE is 11.2. This is option number C. Hello, Arshita.
Yes, sir.
Clear? This
Yes, sir.
आकांक्षा ये आएगा कॉलेज के एग्जाम में जरूर. Do it. Next class we'll start with new chapter, mechanical properties of solid. In DAV they have started that chapter
Yes, sir. They finished
Yes,
the
sir.
chapter.
so fast in one
No.
lecture.
No, sir.
Yes, sir. Means they took 1 week and they finished the chapter.
So
In
now,
my class, they just started today.
Acha, maybe in two different batches they have they are not in parallel. And in JK, which chapter they have started? Same or different? New chapter they started?
So they're still on gravitation.
Yes,
Yes,
lengthy chapter. Yes, yes. And in FS, HFS,
So technically we have our terms going on now, so there are no lectures. But before that, we were doing gas motion of gases.
oh, they started directly mechanical properties of solid gas. Okay, ठीक है, ठीक है, ठीक है. Anmol, at your place, what is going on?
Sir, they have started units and measurements.
Oh, so we are ahead.
Yes.
तो अभी आपको अच्छा समझता होगा ना वो चैप्टर और.
Yes, sir.
Good, good, good. Done? Can I clear it off?
Yes, sir.
If the earth rotates faster than its present value, what happens at the pole? With the help of rotation, what will happen at the pole? If the body is at pole, no effect. Na? At pole, no change, no effect. At equator, apparent weight is mg minus m omega square r. That means if speed is increasing, this negative factor will increase. So apparent weight will decrease. The weight of the body will increase at equator? No, decrease at equator. B option, decreases at equator and no change at the pole. So answer is B. Done. Next one we are doing 35th. Satellite is orbiting close to Earth. What is time period? Time period of satellite is 4 pi square close to Earth. Radius is capital R upon Gm. So this is t square equals to 4 pi square R cube upon R square G. Therefore, t by taking square root is 2 pi root of R by G. This is 2 pi root R by G, option A.
So can you repeat the second step?
Because it is orbiting close to Earth, small r I wrote capital R, and Gm formula we know, R square G.
Okay. Yes, sir. Done.
Next one, 36. A satellite is orbiting in circular orbit. It loses some energy due to collision. By losing energy, it will come down. That means now it will not revolve in this orbit, it will come down. If it comes down from the original orbit, then radius of rotation decreases, na? Hello?
Yes.
So what about kinetic energy? Increases because velocity increases. V also increases. So D will decrease, D matlab distance, V will increase. किधर दिया है? D will decrease, V will increase. D option. And you should know that V is root of Gm by small r. R decreases, V will increase. Shall I clear now this also?
Yes.
Yes, sir.
Next one. Potential energy corresponding to unit mass. Potential means work upon unit mass. This is nothing but potential energy per unit mass. It is called as gravitational potential, therefore C. Next, 38. Its separation of the two masses tends to infinity. So distance tends to infinity. Then gravitational potential energy is minus gmm upon r will tend to 0. Denominator tends to infinity, then this will tend to 0.
Yes, sir.
Okay. Next. What is the potential energy of a mass 0.1 kg from the at the Earth's surface whose G, mass and R are given as 6.67 into 10 raised to minus 11 Newton meter square per kg square, mass 5.98 into 10 raised to 24 kg, and R is 6.37 into 10 raised to 6 meter. Potential energy on the surface is minus gmm upon capital R. So this is minus 6.67 10 raised to minus 11, 5.98 into 10 raised to 24, mass 0.1 is 10 raised to minus 1, R 6.37 into 10 raised to 6. 6.67 and 6.37 approximately I can assume it to be cancelled. So my answer will be greater than, okay, first copy till this. Next. Now see how we can calculate further. 6.67 upon 6.37, I told approximately it is divisible, but answer is slightly greater than 1. So 5.98 से थोड़ा ज्यादा आंसर मिलेगा, that is so guaranteed. So this will be equals to minus of 5.98, 10 raised to minus 24, and 10 raised to, no, plus 24, plus 11. 24 and minus 11 will become 13. 13 minus 1 is 6. 6 minus 6. 13 minus 1 is 12. 12 minus 6 is 6. Check close to this we have 10 raised to 6. D option. Correct? D option?
Yes.
Okay. Next one. The artificial communication satellite remains in fixed position at specific height over the equator. So satellite which remains stationary from any point on the equator of Earth, this revolves in equatorial plane. Earth is also revolving in the same plane. So this satellite is called as geostationary satellite because geographically it appears to be stationary. It is having same frequency as that of Earth, so also called as geosynchronous satellite. Because appears to be stationary, उसको parking भी बोलते हैं, और वही satellite अपना communication satellite होता है. So all are one and the same. So artificial communication satellite is also called as geostationary, geosynchronous satellite, or synchronous satellite. So all of the above. All of the above. Shall I clear?
Yes.
Value of G inside the mine. G at depth is given by G into 1 minus D by R. So if D is increasing, so this factor will increase. Therefore, G at depth is less, GD is less than G on the surface. Less than that on the surface. Okay. Next one, if gravitational force of Earth suddenly disappears, then what will happen? If gravitational force disappear, that means person will feel weightlessness.
Sir, this is with some.
Not given in PDF. I'm not opening. I have not opened PDF. I have opened the booklet. In PDF,
Sir, it is 51st sum.
51st. 51st तो मेरे
Yes, sir.
the escape velocity projected लिखा है. 41 लिखा है 41. एक मिनट रुको, फिर PDF से ही करता हूँ. Wait. Sum number 42. If the body is released from artificial satellite, then it will keep on orbiting along with the satellite. B option. 43rd, theoretical. Value of escape velocity does not depends upon mass, we saw. Does not depend upon direction also. Does not depend upon angle. So correct answer is D. All of these. 44. The escape velocity from the earth is VE. Escape velocity from the surface of earth is V. A body is projected with velocity V greater than V. Then velocity of emergence is root of v square minus v square. That is option. Sorry. Done.
Yes, sir, done.
44. The dash of the planet which are orbiting around the sun remains constant. So remember, angular momentum remains constant. Angular momentum remains constant. What is angular momentum? I think you have not forgotten, you are knowing.
Yes.
Okay, it is nothing but moment of inertia I into omega, or we can say mr square. Omega is v by r, therefore mvr. This is formula for angular momentum. Forty-six. Potential energy of satellite having mass m rotating at height 6.4 into 10 raised to 6. Does it reminds you anything? What is this height? 6.4 into 10 raised to 6. It reminds me it is similar to radius value na, of earth.
Yes, sir.
So here indirectly h is given r. So I know, but h is nr. That means n is 1. जब भी height दिया तो मैं ये shortcut कर देता हूँ. So what is potential energy of the satellite orbiting at height? अच्छा at height पे पूछा है, change नहीं पूछा है. ठीक है, simple है फिर. Minus gmm upon r plus h. Hello?
Yes.
Yes, sir.
Minus gmm upon r plus h is potential energy at height. So this will be minus r square g into m upon r plus r is 2r. So it is nothing but minus of half mgr. Minus half means 0.5.
Yes.
So answer A.
Yes, sir.
47. Assuming Earth to be a sphere of uniform density, what is value of G in a mine? If D is given as 100, D is given 100, R we know 6400. That means it is G into 64 minus 1, 63 upon 64. So G is 9.8 into 63 upon 64. This when you multiply, you will get 9.65, very close to 9.65. 9.65 will be the answer. Because 63 upon 4 is very close to 1. So answer is very close to 9.8. What will be potential energy at infinity? Potential energy at infinity for a satellite? Hello?
Yes.
What is potential energy at infinity for a satellite?
Infinite.
No, remember zero it is. Because there is no gravitational pull, na?
Okay.
Even at center it is zero. So center at infinity, remember both places it is zero. .48. Acceleration due to gravity is maximum at equator? No. Maximum at pole? Yes. It is maximum at pole. Because at pole there is no effect of rotation. So it is maximum at pole. The value of G inside mine, we did this. Ball pen functions on the principle of ball pen gravitational force. That's why that ink comes down. 58. 49 we did, less than value of that at the surface. 51. If the gravitational force suddenly disappears, then weight of the body is zero. Mass of the body is zero. No, only the weight becomes zero. Mass remains constant. 52. Earth shrinks. That means radius decreases by 4%. Mass remaining constant. Then what about G? G formula is Gm by R square. So G is proportional to R raised to -2. Now R is decreasing. So G will increase by power 2 into 4. That means close to 8%. So answer will be G will increase. A.
Yes, sir.
53. If the satellite is orbiting the earth very close, then orbital speed will depend upon very close. Then this is root of gm, small r will become capital R, and we know this is r square g upon r, then so it will become r into g. So that means it depends upon mass of satellite? No. Radius of the earth? Yes. It will depend upon radius of earth only because G is constant. Weight of satellite of the body, weight of the body as recorded by spring balance suspended in the earth's satellite. Spring balance works on pulling force, but at the in satellite person feels weightlessness. So in satellite it will record 0. Answer 0. Time period of simple pendulum in satellite, orbiting satellite. time period of simple pendulum is given by 2 pi root L by G. So in satellite G is 0. Therefore it is 2 pi root L upon 0. So time period will become infinity. Time period will be infinite. Can I clear this?
Yes.
56. If distance between Earth and Moon is doubled, so R2 is double R1, then gravitational force between them. Gravitational force is inversely proportional to square of distance. So F1 upon F2 is R2 upon R1 square. So F1 upon F2 is double R1 upon R1 square. Therefore F1 upon F2 is 4 by 1. So new force will become 1/4 of original. It will become 1/4 of original, that is 57. An artificial satellite orbiting Earth does not fall down because the necessary acceleration, because it produces, is balanced by attraction of moon, no, produces necessary acceleration for its motion in the circular path. B. It produces necessary centripetal force. Force means acceleration. Body of mass m is taken from Earth's surface at a height which is equal to radius. Then what is change in potential energy? Can you tell here what is n? 1.
Yes, sir.
So our change in potential energy, n upon n plus 1 mgr, 1 upon 1 plus 1 mgr. That means it is half of mgr. Half mgr is given in B. Can I clear this now?
Yes.
Come to next sum number 59. Period of satellite in circular orbit of radius r. Circular orbit of radius r is t. The period of another satellite in a circular orbit, of radius 4r will be how? See, this r is not radius of planet, it is radius of orbit of satellite. So we know time square is proportional to orbital radius ka cube. So T1 upon T2 square is R1 upon R2. That means T upon T2 raised to 2 is R1 R upon 4R cube. So T upon T2 is 1 upon 64. T upon T2 is 1 by 8. Therefore, T2 is 8 times T. Option B. T2 is 8 times T. Done? Hello? Done this one?
Yes, sir.
Okay. Sum number 16. Two satellites are having masses m1 m2 such that m1 is greater than m, are revolving around the earth in a circular orbit of radius r1 greater than r. Which of the following statement regarding their speed is correct? B is root of gm by r. So this capital M is mass of planet. This is satellite. So satellite पे depend नहीं करेगा. So V depends upon only orbital radius. Because R1 is greater, therefore V1 will be less because it is inversely proportional. V1 less is given in C. Right? Next one. Escape velocity from the surface of Earth in upward direction is 11.2 kilometer per second. If it is projected in the direction 45 degree with vertical, what will be the escape velocity? Escape velocity is independent of direction. Satellite should come out whichever direction chalega, independent of direction. Therefore, VE will remain same 11.2 kilometer per second. Please do 61. Next, a geostationary satellite is orbiting at height of 6r. That means radius of orbit will be r plus h1. That will become r plus 6r equal to 7r. Geostationary satellite means it is communication satellite. Time period is 24 hours when it is orbiting at 7r. The time period of another satellite at a height of 2.5 r. Height of 2.5 r. So radius of orbit is r plus h. That will be r plus 2.5 r. That is 3.5 r. So I know radius of orbit. I have to find time period of this satellite. First satellite is geostationary or communication. That means its time period is 24 hours. New satellite time period we want, its orbital radius is given. P square is proportional to r cube. P square proportional r cube. So T1 upon T2 square will be R1 upon R2 cube. That means T1 upon T2 will be 7R upon 3.5R cube. That is 2 cube. T1 upon T2. 2 cube means 8, correct now?
Yes, sir.
And what is square root of 8? Can I write 2 root 2?
Yes, sir.
So we get T1 upon T2 square first 8, then square root of 8 is 2 root 2. So T1 upon T2 square equals to 8. T1 upon T2 is 2 root 2. Therefore T2 equals to T1 upon 2 root 2. Therefore T2 is 24 upon 2 root 2. So T2 equals to 12 upon root 2. When I rationalize 12 root 2 upon 2, 6 root 2. 6 root 2 hours.
Done, sir.
So we have completed gravitation. Just 3 definitions are left out. What is Kepler law? Communication satellite, feeling of weightlessness. So 15-20 minutes I will do that on Monday and start with new chapter, mechanical properties of solid. That is very small chapter. In 1 week we can complete.